Good day, everyone. So this is a quick overview of backtesting tools I wrote based on Interactive Brokers TWS API. This is a data accumulation tool. Its main purpose is to just pull a lot of data to your local storage so that you don't have to rely on internet every time you want to backtest anything. Of course, it is much more convenient to use PCIe 3 or PCIe 4 or even SATA speed against internet speed. So this is basically downloads 52 weeks of daily candles per request and just saves it. Then we got this file which uses our previously downloaded daily candles as a template. That way we ensure that nothing gets downloaded twice and nothing gets missed. We got a 100% guarantee that all the days this script downloads are actual days that market was open. It uses download symbols. This is another template which contains stock symbols and starting date for each of them. Also, we can use the same date for every stock. It downloads them. Here it corrects them. What does this function do? When you deal with numpy arrays, they have to be basically like square, plumb, and true. They have to be symmetrical all around. You can't have any gaps. The days have to be the same length. The candles have to be the same length. And when you deal with pre-market data, this is not always the case, because pre-market data can be very thin because some stocks just don't have enough pre-market data. So what this does, it masks missing candles with previous candles and zero volume. Because otherwise we would have to deal with a lot of unnecessary logic and error handling. Because, for example, you want to compare some cumulative data from 8 to 9 a.m. and some stocks just don't have it. Some stocks just have one candle at 7:30, another at 7:50, another at 9:56. And we don't want this to return an error. We want this to return like no match. We just don't. We want this program to skip it because this is a no match. The condition is not met. So what this function does basically, it fills the gaps with the previous candles and zero volume. So it either it's gonna be dojis like this, or it's gonna be like regular candles, the same candles but no volume. But the data, this makes sure the data is always continuous. Both files write logs to txt files, which you can look over and see if anything returned an error. Nothing is supposed to return an error. Then it downloads it to the purgatory folder. Let me show you. This is the folder. Downloads it to there. And after everything is downloaded, you need to do two things. First, you need to move whatever was downloaded. Wait a second here. Whatever was downloaded here, you have to move to the done dictionary, just copy paste it. Of course, this could be automated, but just I didn't feel like it because it wasn't too much work. And from this point, it moves it to the maintain list. And maintain list is handled by these two scripts, which basically do the same as these two, but they just pull the most recent day, the last day. And one level like of additional logic here included. You don't really know which day is going to be the holiday, because for example in Windows scheduler you can just schedule which days it runs. For example, you schedule them to run Monday through Friday, and some days are going to be national holidays and market is going to be closed. So here the logic is included that makes sure it downloads and writes to the large database only those only those days which match like the current day. So for example, if it downloaded yesterday's day and it doesn't match the current day, no one gets written into the large database. Your data is safe, no duplicates will be created, and it's going to write to the logs that it is a date mismatch. So after it downloaded everything, you launch this script, and what this script does is basically like another level of tests and normalization. It makes sure that every day is the same length, every candle is the same length, every day starts at the same day. Everything is basically ready to be processed. It removes the old files and writes the new files into the storage folder. This is going to be a folder for your clean data. And after that, you want to backtest it. So this is like a sample backtesting file. You download the file, you split them into whatever time frame you want. You split them into three-dimension array. So this is going to be like one dimension. This is going to be like one dimension. This is like the large container. This is going to be day, and within days they're going to be day, candle, candle, candle. This is going to be a three-dimensional array. And for example, we want to find some strong closes on Apple. So we type here Apple. Of course, this could be looped, and it can go through like the list of stocks. For demonstration purposes, this is going to be like only one stock. So we put Apple here. We create a folder that it's going to be just easier for us to navigate and find these files. And we use functions from conditions file. This is just wrappers to remove abstraction and make it all convenient and human readable. So for example, you want strong close on Apple in year 2019. So the day is going to be green, obviously. So day close is more than day open. Of course, you can put some percentages here. So like 10%, really highly volatile stock. And high of day, we're interested in strong closes at the very end of day. So high of day after 1545, this is a Boolean function. And high after day 1545, the highest point since 1545, is higher than the highest point before 1940. And we want this breakout basically to hold. So daily close is also going to be higher than the high before 1540. So this is basically, we'll pull some matches. Some days will match this condition. What do we do with the days? We could return just the date. Just the date, and then manually go through all of them in Thinkorswim on demand. But it could be much more convenient to have just at least like a rough sketch of what happened that day, so that you could filter out your results more accurately, maybe come up with more conditions, just, see actual charts. So what this function does is basically creates pictures of little charts, which would let you, visually assess, maybe this condition is incorrect. Maybe this condition needs more kind of strict rules. Maybe this filter needs more of these small conditions. So it takes a while because this is graphics. Graphics is no joke. But it creates this folder, Apple strong close, with all the matches of charts of days that matched this condition. And what this does, basically, like, for example, I'm interested, maybe what happened the next day. Maybe that would have been a great overnight hold, you know. So what this function allows you to do is basically like pull the date this condition matched and pull days before and days after. For example, here I pulled 1 day after the day where this condition matched. And here's what we got. This is just a basic chart. You can plot really anything. Please disregard this is split adjusted data. This is real Apple data, but this is split adjusted from 2019. Just make a chart, but you can plot whatever, like moving averages, VWAP, standard deviation, Bollingers, whatever, because we are in control. Here it just pulls, you know, volume and candles. About indicators, you can add basically whatever indicators you want. This is just a sample of what you can do. Add simple moving average, add exponential moving average, add gaps, dollar range, percent range, anchored VWAP, midpoint. What this does is basically stacks new columns. And what you can do with these columns, so this loop can be written like a nested loop. So for example, for day in large array, for candle in day, and here you can basically, I can write the same kind of wrappers as this. So, and you can look for matches. For example, if high of a candle candle high is larger than, I don't know, some kind of indicator that we wrote, for example, like standard deviation. That would be like candle, standard deviation number would be added to the large array of candles. So that would be like candle and whatever index, whatever like consecutive number of a column this standard deviation is. But I can always write, you know, human readable wrappers. So that would be like, I don't know, something like this. And you can print like date and time of this candle. Or you can use the same function to print those days where basically this match happened. And another thing I built, this is for a client, so I'm not going to show like any inner details, but this is a option scanner that pulls tick data for options. The client wanted it to be implemented in CSV. So what this basically is all the options that meet certain criteria: time and sales, VWAP, bid and ask 5 seconds from the trade. So basically this is it. Thanks for watching. If anyone is interested, my contact information is in the video description. Have a great day.